Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
It is difficult to compare the ignition system in terms of importance for the car with the powertrain. But it can be unequivocally stated that a significant part of the problems, if not the majority, associated with unsuccessful or problematic engine starts are caused by faults in the ignition system. Its operation is controlled by several types of sensors. Today we will get acquainted with one of them, Hall sensor. We will find out what it is needed for, what functions it performs, how it is organized, and in what cases it fails. In short, the information will be quite enough to be able to diagnose this device yourself and perform, if necessary, repair the sensor or replace it. Functions of the Hall sensor in the car. Strange as it may seem, but this is the only sensor installed in a modern vehicle. The name of which includes this sensor is the only one in the automobile that has a proper name. Edwin Hall, famous American physicist of the second half of the 19th century, it is named after the famous American physicist Edwin Hall, who was the first scientist to investigate the behavior of semiconductor materials in interaction with a magnetic field. Strictly speaking, the Hall sensor is responsible for fixing the magnetic field. It is done in the following way. A semiconductor in the form of a flat plate is placed in the area of the magnetic field. When voltage is applied to it, the current under the influence of magnetic field lines shifts to one of the edges of the plate, creating a potential difference that can be detected. In the case of an automobile DC, it is used as a key or relay. In the trembler, there is a magnet, which at the moment of starting the engine begins to rotate, interacting with the sensor. The latter catches the magnetic field and gives an electrical impulse that provokes the formation of an ignition spark. Thus, the DC is a mandatory element of the ignition system. But in some cases it is also used for other purposes. In digital speedometers/tachometers, for controlling the functioning of ABS, for checking the characteristics of transmission wheels, etc. The Hall sensor is characterized by its simple design and, consequently, high reliability. It is practically not subject to wear, and all its failures usually occur due to contamination or external mechanical impact. As a rule, the DC is installed in such a way that it can be easily dismantled and put back in place. Principle of operation of the Hall sensor. Although the Hall effect itself was discovered and patented back in 1879, it took more than 70 years before devices operating on this principle began to be produced industrially, helped in no small part by the revolutionary discoveries in the field of semiconductors. That occurred in the middle of the last century. The first microcircuits, although characterized by rather large size and imperfect technical characteristics, turned out to be quite reliable and were used in generators named after the American physicist. As electronic components were miniaturized, really compact sensors of analog or digital mode of action appeared. In this case, the principle of operation of the Hall sensor can be linear. This is how devices measuring current, flow of technical fluid, vibration force work, and logical, measuring speed, number of pulses, proximity sensors. Few people know, but even in the CD/DVD drive of computer, video, or audio equipment, there is a device that measures the EMF using the Hall method. But the most widespread use of the DC is in the automotive industry, where it is used to measure the position of the crankshaft/camshaft. As an ignition spark initiator in non-contact electronic ignition systems, this device is able to read the necessary information and transmit the received data to the controller, ECU, or directly to the executive device, which ensures the normal functioning of a particular car system. As an example of how the Hall sensor works, we can take the system of ignition of the working mixture. In this case, the rotation of the camshaft gear wheel initiates the occurrence of a potential difference detected by the sensor, which sends the appropriate signal to the onboard computer, which, based on this information, determines the time of ignition of the fuel mixture in the combustion chamber. If the vehicle powertrain is equipped with a system that provides automatic phase change, the controller is located directly on the camshaft valves, where the DC is located. The device responsible for determining the ignition timing is usually located in the trampler. This sensor is used instead of contacts, being a more reliable replacement in the composition of contactless electronic ignition systems. To see it, you need to remove the cover of the trampler, as well as the runner and some other parts. It is located in close proximity to the trampler shaft, on the plate next to the permanent magnet. From above, the sensor is covered by a magnetically conductive plate with teeth in the form of a crown, the number of which corresponds to the number of cylinders of the power unit. A pad with wires is installed outside the distributor, through which the communication between the sensor and the ECU is carried out. DX, installed on the camshaft, is usually mounted on its rear cover. Hall sensor looks like a cylindrical part, placed in a housing made of durable plastic, on the outside of which there is a connector for connecting the wiring harness. From above, you can see the plate with slots. DX device. We have already noted that in the car sensors that work on the principle, invented almost a century and a half ago, can be used for a variety of purposes, but it is a mandatory component only in the ignition system. Read also, what is the need for a pressure gauge? Types, rules of choice and use. Therefore, it makes sense to describe the device of the Hall sensor of this particular type. It consists of a microcircuit realizing the capture of the voltage change on the plate, a permanent magnet, a plastic housing, rotor, blade, a contact group, magnetic conductors. Despite the relative large number of components, such a sensor has a number of undeniable advantages. Thanks to the miniaturization of modern microcircuits, it has compact dimensions. In electrical engineering terms, the electrical signal generated by the sensor has a clearly defined rectangular shape. When turned on, it almost instantly takes a certain stable value without smooth rises and falls, which is extremely important for digital devices such as a controller. In a sensor measuring crankshaft speed, the dynamics of the response frequency, as a result of changes in engine speed, does not lead to a mismatch of the measuring moment. However, there are also disadvantages of the DCS. The main one is the low sensitivity of the device, which can be significantly affected by external electromagnetic interference formed in the onboard electrical circuitry of the car as a result of the work of a large number of electronic/electrical devices and appliances. The higher cost of the Hall sensor compared to analogs of magneto-electric type of action is leveled by the simplicity of large-scale production. As far as reliability is concerned, the vulnerability of the Hall sensor lies in its poor protection against electrical interference. But it has no or minimized mechanical components that are subject to rapid wear. Possible faults. Although the Hall sensor is one of the most reliable devices of its kind, it is still subject to failure. Nothing in nature lasts forever, not even atoms. But it is necessary to distinguish between complete inoperability. In this case, we simply cannot start the motor, and partial, when there are certain difficulties with starting and operation of the power unit. How to determine that the DC is defective? This can be judged by the following symptoms. Fuel consumption has significantly increased. Usually this is because the fuel injection is performed more often than it should. Once per crankshaft revolution, the engine started to run unstably, with inexplicable stalling, which is manifested by jerking, especially when gaining speed. In some cases, it is simply impossible to accelerate above 50 kilometers per hour. The power unit stalls on the move, the engine starts with difficulty, or refuses to start at all. Note that the listed signs of Hall sensor malfunction are not authentic, and this is characteristic of almost any abnormal behavior of the car. In other words, each of the above-mentioned malfunctions may indicate problems with our sensor, but not necessarily. The same symptomatology is observed in the breakdown of a number of other assemblies and parts of the car. That is why it is so important to be able to diagnose this important device for the ignition system, which is a rather laborious and non-trivial task. Troubleshooting. In principle, the Hall sensor rarely breaks, but if it does, car manufacturers advise to simply replace it with a new one. But since the cost of the device is not small, especially if we are talking about a foreign car, and here the following rule works. The more prestigious the car, the more expensive the spare parts for it. Many car owners prefer self-repair. In principle, the design of the sensor is relatively simple, so there should be no special difficulties in its restoration. As an example, Let's consider the algorithm of repair of the DX, installed on some models of Volkswagen. Usually the most susceptible to breakage is the logic element of the chip, labeled with the sequence of symbols S441A. Actually, he is the heart of the sensor, registering deviations in voltage on the working plates. Our task is to replace it, for which we have to perform the following actions. Of course, we can't do without purchasing a new logic element. Its analog can be quite suitable. The purchased part should be tested for operability beforehand. This is done in the following way. You need to connect an ordinary LED and a resistance of 1 to 2 ohm in a chain, and then connect this design to the output and plus pins of the chip. The value of voltage, which should be powered logic element, should vary within 3 to 30 V. This is enough to make the LED light up when the chip is exposed to a powerful enough magnet. In the middle of the sensor with a drill with a diameter of 8 to 10 millimeters should be made. A hole, cut the wires flush so that they do not look out, and then with a fine file in the body cut grooves in which the new wiring will be laid. Attach the failed logic element in the window and install the DC in place to check its operability. At the moment when the shaft shutter passes through the slots of the crown, the LED should light up. When the slot goes away, the LED goes out. If nothing works, it is the polarity of the plus and minus pins. They just need to be swapped. If our circuit with LEDs works, it remains to perform pin out of the chip through the grooves made. To do this, the wires are soldered in the window, the ends of which should be connected to the connector. Here again it is important not to confuse the polarity of the pins. On the trembler connector they are labeled as plus, dash, and 0. After soldering, carefully inspect the wiring for damage. Test the sensor with a multimeter for short circuits. If everything is normal, we seal the technological hole made by us, preferably the grooves too, with heat-resistant glue. It remains to install the DX in its original place and test all wires for the absence of short circuits. They should not be dialed to the body. Read also, why do you need solenoids in the automatic transmission and how to check them yourself in principle, in exactly the same way you can restore the operability of the Hall sensor on other brands of cars, because fundamentally they are all similar to each other. The differences may lie only in the geometry of the components of the device. In some cases, e.g., mechanical failure, the DX cannot be repaired, and then you will have to buy a new part and replace the entire sensor. This is an uncomplicated operation, which can be done even by novice motorists. Here is the algorithm of the procedure. Dismantle the trampler itself without disconnecting its wires. Remove the cover, align the timing marks with the mark located on the crankshaft. Fix the position of the trampler. Remove the fasteners, clips, and stoppers. Remove the shaft. Unscrew the DC terminals and the sensor itself with a screwdriver. Carefully remove the device by pulling out the regulator. Install a serviceable sensor and perform all operations in reverse order. Again, the described algorithm is suitable for most makes/models of cars, with few exceptions. Checking the performance of the DCS. Unlike mechanical parts of the car, the malfunction of which is often determined purely visually, this trick does not work with the Hall sensor. Of course, if it has been subjected to appreciable mechanical impact, for example, when repairing the trampler, then its plastic housing will have traces of impact, and this will be a good reason to check the performance of the sensor. Just like when inspecting the wiring and identifying problem areas, bare insulation, burned contacts, etc. Other symptoms that appear in the power unit operation may also become a reason for such actions. It began to start badly, unstable. Operation in the idling mode. When the engine is running at higher speeds, unpredictable dips are observed, manifested by twitching of the car. The engine may simply stall at the most inopportune moment. If you are not good with technology and have never worked with electrical measuring devices before, it is best to contact the specialists of the nearest car service center, who will check the Hall sensor with the help of an oscilloscope, which allows you to identify the most minor deviations in the operation of the device. But in principle, you can check the Hall sensor with a multimeter by yourself, and there are several ways to perform this procedure. Of course, the most cardinal of them is to install a known working sensor and check it in operation. Of course, this method is applicable if you have a good friend who is ready to give you his device for some time. But if you have such an opportunity, this is the easiest way to make sure that the DX is viable. If such volunteers could not be found, it is worth trying another method, for which we need a tester. On a running motor, you need to check the voltage at the output of the sensor, which should be in the range of 0.5 to 11.0 V. If this is not the case, the boron is defective and must be repaired or replaced. Finally, it is possible to check the operation of the DC by using the so-called simulation method. It consists in disconnecting the pad from the sensor, turning on the ignition without starting the engine, and connecting the sixth and third outputs. Sparks will indicate that the device is not working in the normal mode. That is, it is defective. Consider another way to check the Hall sensor, also not requiring a voltmeter/tester. Connect the spark plug with its contact to the lead wire of the ignition coil. Short the threaded part of the spark plug to ground. Dismantle the carriage together with the Hall sensor, then connect the connector. With the ignition switched on, use any metal object, wrench, or screwdriver near the DC. The presence of spark on the spark plug indicates that the device is in good working order. We have already talked about simple sensor testing. Recall, we are talking about checking the presence of power supply on the device, which requires the connection of an ordinary LED and a resistor with a nominal value of 1 to 2 ohm in one electrical circuit. In this case, the sensor is disconnected from the plug box, connecting one end of the assembled circuit in terminal number 1 and the second to the third terminal, followed by turning on the ignition. If there is a voltmeter, it would be enough to measure the voltage on the legs of the device, but in our case there is no tester. So the LED will light up to indicate that everything is okay with the supply voltage. But if the LED does not light up, it may mean that we simply mixed up the polarity of the connection, and this is important for semiconductor devices. Change the polarity and turn on the ignition again. If the bulb does not show any signs of life in this case, we continue our experiment. To do this, leave the first terminal in the same position and transfer the wire from the third contact to the second one. Turn the camshaft, for example, with the starter, although you can do it manually in any convenient way, and watch how our LED reacts to this. If it blinks with high frequency when the ignition is on, the Hall sensor is good and does not need to be replaced. Otherwise, a more thorough diagnosis of the device, performed on an oscilloscope, will be required. Most likely, you do not have such a measuring device, so you can either show the sensor to a specialist or do not bother and immediately buy a new one. In conclusion, we have explored the Hall sensor from A to Z, delving into its principles, applications, and advantages. Understanding how Hall sensors work and where they can be effectively utilized opens up a world of possibilities in various fields, from automotive to consumer electronics. As technology continues to advance, the role of Hall sensors will only become more significant, driving innovation and efficiency. Thank you for joining us on this journey, and we hope you now have a comprehensive understanding of Hall sensors and their impact on modern technology.